Has anyone ever revealed to you how to make a DIY antenna from a 5-way signal splitter? In real life, this splitter is typically used to divide a single TV or internet signal source to 5 different devices. In this video, I'll show you how to turn it into an antenna. Let me show you how. Let's get started. Next, I use a short piece of coaxial cable to interconnect the auxiliary ports on the signal splitter. This technique allows the signal to circulate alternately rather than traveling in a straight line, accelerating wave propagation for faster reception. However, don't rush to do it just yet. Watch until the end, and if you find the final results effective, feel free to try it out. And you may not know this, but coaxial cable represents a groundbreaking milestone in telecommunications history, serving as the core backbone for high-frequency signal transmission for decades. Invented in 1880 by mathematician Oliver Heaviside, this cable features a superior 4-layer concentric structure: a central copper conductor, a dielectric insulating layer, a metallic shielding mesh, and a protective outer jacket made of polyvinyl chloride. What makes it special is that the electromagnetic signal is contained entirely within the insulation between the inner core and the shield. As a result, the cable achieves near total immunity to external interference while preventing signal leakage. Operating at standard impedances of 75 ohms for television and antennas, and 50 ohms for radio equipment, coaxial cable can transmit a broad frequency range from kilohertz to gigahertz with extremely low attenuation. Thanks to its high durability and exceptional stability, coaxial cabling remains an irreplaceable infrastructure in modern telecommunications, satellite, and broadcasting systems. And this is a straight F connector, a compact yet essential component in any telecommunications setup. Featuring a standard threaded design, it ensures a tight, precise junction between the coaxial cable and the splitter ports, effectively minimizing signal loss and interference to maintain peak transmission performance. The other end of this cable will be connected directly to the mounting tab of the signal splitter. As I mentioned earlier, while this technique is remarkably effective, explaining its performance in purely theoretical terms is quite difficult. Only when the entire antenna assembly is fully constructed can you truly observe the actual results it delivers. Instead of stopping at just the 2 coaxial cable pieces we prepared, I'm going to make 2 more just like them, bringing the total to 4. Having all 4 is essential to complete the full antenna assembly. Alright, now let's see how I connect these coaxial cables to the signal splitter. So, a small antenna assembly is complete. Now, I will secure it to the base and proceed to add the signal transmission module. As for the antenna base, I've already prepared it in advance. However, feel free to unleash your creativity and build the base using your own unique ideas. Hot melt glue is an essential material I frequently use to securely join components that seem completely unrelated. Next, I've prepared a longer piece of coaxial cable to serve as the main transmission line, transferring signals from the recycled antenna unit to the receiver. For the end of the coaxial cable connecting to the TV, alongside a straight F connector, I'm also adding a 90-degree right angle F connector. This right angle adapter is super practical. It keeps the cable flush against the back of the TV, prevents tight bending or snapping, and saves valuable space, perfect for wall-mounted TVs. Before connecting this recycled antenna device to the TV, I want to check first so you can clearly see that at this moment, the television is not receiving any signal at all. Just a few seconds after making the connection, the picture has already appeared on the screen. But we won't jump to conclusions yet, let's keep testing for a while longer to see whether the signal remains stable or not. Even though the signal still seems stable so far and nothing unusual has happened yet, to test it more carefully, I'm going to disconnect it and plug it back in once again to see what happens. And that is how you build a unique DIY antenna from a signal splitter. With just a few simple steps and virtually zero cost, you now have a powerful device for crystal clear reception. If you found this video helpful, don't forget to like and subscribe to support the channel. Good luck with your project, and see you next time.